Today we're going to discuss transformations of parent graphs, and this is going to be day one of our notes. This first box gives the rules for transformations of f of x. So f of x is going to be our parent function to g of x. So g of x is our transformation. And we're going to learn a way to write g of x in terms of f of x with all of these constants. A, B, C, and D are constants. Okay, they're number values that cause transformations to the parent function. I'm hoping that this is a review, but if you take the negative of f of x, that's going to be a reflection over the x-axis. If you multiply f of x by a constant, it's going to be a vertical change by a factor of the absolute value of a. So it's going to be a stretch, which means it gets bigger if the absolute value of a is greater than 1. And it's going to be a shrink. It's going to get smaller if the absolute value of a is less than 1. If you add or subtract a value d from f of x, it's going to be a vertical shift up for d greater than 0, a vertical shift down for d less than 0. So these first three transformations, so the negative outside of f of x, a, and d, all cause vertical transformations. The changes occur outside of f of x, so the output is affected. This means our y is changing. Our next three show the horizontal transformations. So if the x becomes negative in the input, it's going to be a reflection over the y-axis. If the x in the input is multiplied by a factor, it's going to cause a horizontal change by a factor of 1 over b. This 1 over b is important, okay? It's not just b like it was with a vertical change. It's the reciprocal of b, okay? And it's going to be a stretch if b is less than 1 and a shrink if b is greater than 1. Anytime you're dealing with something inside, I try to think I'm dealing inside and inverse. So reciprocal and inverse seem related to me. Our last one, again, if we're in the input and we're adding a value c, it's going to cause a horizontal shift right for c negative and a horizontal shift left for c positive. These changes occur inside of f of x, so the input is affected. This means x is changing. It's also helpful to remember that inside relates to inverse functions. The order of your transformations is important. I always think that I work my way out from what is happening with x. So here is x. My next thing closest to x is c. C deals with my horizontal shift. My next thing after I've taken care of c is b. B deals with my horizontal stretch or shrink. I'll also have to decide if it's negative, I'm going to deal with a horizontal reflection. Next, outside of there, I'm multiplying by A, which deals with my vertical stretch or shrink. And if it's negative, it deals with my vertical reflection. And then working outside again, my last thing is a vertical shift. Sometimes this gets a little confusing because you can do, especially your vertical transformations, in different order and get the correct graph. But your horizontal transformations definitely need to be done in the correct order. So I think it's easiest to remember, like I said, to work out C, then B, then if B is negative, then A, then D. Okay, so this is a lot. I would suggest having this box with you, especially as you work through the problems this week and for your quiz or your test on this. Okay, I think the more you do it, the more practice you do, it will come faster to you, especially if you're trying to remember go from the inside out. But I think this is definitely useful information and something you should have close to you while you're doing your work this week. So for our first example, we want to rewrite each function g of x in the form g of x equals a times f of b of the quantity x plus c plus d. Then we want to identify a through d and describe the transformations from f of x, our parent graph, to g of x, our new transformation graph. And we want to be sure to write the transformations in order. So I see that my f of x is x squared. I can see something squared here. So I am going to write my g of x is f of, and what's being squared, right? Because f of x tells me my input is squared. So this is f of x plus 2. So that means my squared can go away because f of x plus 2 would be x plus 2 squared. And I can put a negative 3 in front. So g of x is negative 3 times f of x plus 2. So let's just check this. So this would be my answer, but let's see if I evaluated this, right? So g of x would be negative 3. Let's see what f of x plus 2 is. So f of x is my input squared, and my input here would be x plus 2. So that is the equation that I wanted. So now I am actually going to rewrite this. If you can see everything from here, that's fine. But just to be completely explicit, this is going to be negative 3f. I want something b times x plus c. So I already have an x plus c. And I'm going to notice that I can multiply that by 1. Okay, usually we would not put that 1, but we're putting it here just so I can be totally explicit. And then I don't have a constant afterwards, so we can remember that that's plus 0. So now my a is negative 3, my b is 1, my c is 2, and my d is 0. Okay, and again, I am just comparing that to a f of b times the quantities x plus c plus d. So now let's go in the order that our transformation said. So it's going to be we have c is greater than 0, so it's going to be a horizontal shift left. So shift, we don't even have to write shift. So this graph, we're going left 2 units. So b is 1, so we're not changing the horizontal change at all. Then we are going to have a vertical stretch by a factor of 3. I should have done that shorthand. I should have said vertical stretch of a by factor of 3. I guess it's probably 1/6 of one, half dozen of the other. Then I can see, because of my negative, that I have a vertical reflection. And I can see I have no vertical shift. Okay, so I had 3 of these change, and I had 3 changes to the graph. Okay, 3 transformations, 3 steps in my transformation. Okay, let's look at B. This time I have an absolute value function as my parent function. So I want to rewrite my g of x. So I can see that g of x, nothing is changing it in my input, right? I have absolute value x here. I have absolute value of x here. So I just have, where I see the absolute value of x, I can just replace it with f of x. And I can see that this is 1/2 that original parent function minus 4. So now I can see that a is 1/2, b is 1, c is 0, and d is -4. So again, looking back up here, A, I need to go in order, right? B is 1, so that means there's no change. C is 0, that means there's no change. So now I want to work out. My A of 1/2 means I have a vertical shrink by 1/2. Oops, sorry. So I have a vertical shrink by 1/2, and I shift down by 4. Okay, again, this is important. Order is important. When you are telling me the transformations, it's important that you say left, right, up, down. If it's a shrink or a stretch, it's important that you're telling me vertically or horizontally. Let's try our next one. I can see that f of x is x cubed. I can see that I have a factor cubed. This is a trick from getting to know it better. I know that I want to write this in terms of a number times x plus c. So I am going to factor out a 2. So this becomes x minus 1/2 cubed. Okay, so now this is equivalent because 2 times x would give me 2x. 2 times -1/2 would give me the -1. So here I see that A is, I'm just comparing again, A is 2. No, sorry. A is 1. B is 2. C is -1/2. And D is 0. So now, working from the inside out, this is going to be, I'm going to move right 1/2 unit, right? Because C involves my horizontal shift or left or right, and it is right if C is less than 0. And then I am going to have a horizontal shrink by 1/2. Okay, and I know it's going by 1/2 because my horizontal shrink or stretch is always the reciprocal. So the reciprocal of 2 is 1/2. Pause the video and try to write letter D in terms of f of x. Okay, so my f of x is the square root. I can see that my new input is 3 times x minus 3, right? I just factored here. I multiply the square root expression by -2, and then I add 7. So now my A is -2, my B is 3, my C is -3, and my D is +7. So lots going on with this graph. Starting on the inside, I'm shifting right by 3. Okay, right because my C was negative. I am horizontal shrink by 1/3. I'm running out of time. So I have a horizontal shrink by 1/3, a vertical stretch by 2 because of this 2, a vertical reflection because of